3 states are incinerated in minutes. 4 more are buried under a weight so immense they cease to exist. This is not a theoretical model. It is a geological certainty. Deep beneath the geysers and forests of Yellowstone National Park, a system of magma, 11 times the volume of the Grand Canyon, is breathing, right now. And geologists have mapped exactly what happens when it finally exhales. The initial blast wouldn't be an explosion, it would be an erasure. The land itself vaporized by pyroclastic flows, moving at the speed of a hurricane. Gone. Completely gone. What do you think is the most misunderstood part of this threat? Let us know in the comments below. A lot of you who watch these critical briefings forget to subscribe. If you believe this information is vital, then helping this channel grow is just as important. Take 1 second, hit subscribe, and turn on notifications. You won't want to miss what comes next. Let's begin. The first to disappear is Wyoming, the epicenter. The state ceases to be a place and becomes a source point for the eruption column, a pillar of ash and glass punching 30 miles into the stratosphere, 5 times higher than a commercial jet flies. Anyone inside Yellowstone National Park itself, and for 100 miles in every direction, is subjected to temperatures and pressures that are not survivable. The ground shock alone would register as a cataclysmic earthquake. But that's the footnote. The real agent of destruction is the pyroclastic flow, a ground-hugging avalanche of superheated gas, ash, and rock fragments moving at over 400 miles per hour. It doesn't burn things, it atomizes them. Next are Montana and Idaho. The pyroclastic flows, unconstrained by terrain, will race across the plains and up over the mountain ranges, blanketing the southern half of Montana and the eastern flank of Idaho. Cities like Bozeman, Jackson, and Idaho Falls aren't just hit, they are scoured from the map. The flows are so hot and so fast that there is no warning. The sky darkens, and then the horizon simply dissolves into a boiling gray wall of destruction, moving faster than sound. These 3 states, Wyoming, Montana, and Idaho, form the kill zone, the area of immediate, absolute lethality. Survival here is not a matter of preparation, it is a mathematical impossibility. But the eruption is just getting started. The true catastrophe, the one that erases the next 4 states, is not from the blast, it's from what comes next, the fall. The eruption cloud, an umbrella of pulverized glass and rock spanning 1,000 miles, begins to drop its payload. And this is where the continental map is truly rewritten. Utah and Colorado are next. The USGS Ash3D model, the definitive projection co-authored by geologists like Dr. Larry Mastin and Dr. Alexa Van Eaton, shows a thick, heavy blanket of ash falling across both states. Not a dusting, not inches. In many areas, more than a meter. 3 feet of fine, abrasive, heavy material. Volcanic ash is not like campfire ash. It is rock and glass shattered into microscopic shards. When it's dry, it's heavy enough to make roofs groan. When it mixes with the slightest bit of moisture in the air, it turns into a substance with the consistency and weight of wet cement. A single meter of this ash is enough to collapse nearly any standard residential or commercial roof. Every building in Salt Lake City, every home in Denver, every structure not specifically engineered for this impossible load, fails. The power grid is the first casualty. The ash, carrying a strong electrostatic charge, shorts out transformers and brings down power lines, plunging the entire region into darkness. But the darkness is already there. The sky is black. Day becomes a permanent, suffocating night. Nevada and South Dakota complete the list. While prevailing winds would normally carry the plume east, a supereruption of this magnitude changes the rules. It makes its own weather. Dr. Mastin's research confirmed that the sheer scale of the umbrella cloud generates its own high-pressure wind fields, powerful enough to drive ash westward, directly into the jet stream. Against the flow, Nevada, a state that should be upwind, finds itself buried. The agricultural heartland of South Dakota is sterilized. 3 feet of powdered glass smothers every field, chokes every river, and poisons every reservoir. The American breadbasket becomes a sterile gray desert. These are the 7 states that vanish first. 3 are scoured clean by the blast. 4 are crushed under the weight of the sky itself. And for the rest of the country, the nightmare is only beginning. To understand how this is possible, you have to look beneath the surface. Miles down, Yellowstone is not a mountain with a hole in the top. It is something fundamentally different. Geologists classify it as a supervolcano, a term reserved for a volcanic center capable of a magnitude 8 eruption on the Volcanic Explosivity Index, or VEI. A VEI 8 event is one that ejects more than 1,000 cubic kilometers of material. That's enough rock, ash, and pumice to bury the entire state of Texas 5 feet deep. To put it in terms that mean something, it is an eruption 1,000 times more powerful than the 1980 eruption of Mount St. Helens. It is an event on a geological, not a human scale. The engine that drives this is a mantle plume, often called a hot spot, a column of intensely hot rock rising from deep within the Earth's mantle, a part of our planet we have barely mapped. This plume is stationary, but the North American tectonic plate is not. For the last 17 million years, the continent has been slowly drifting southwest over this stationary blowtorch. The evidence of its journey is written across the American West, a trail of ancient, extinct calderas stretching across Oregon and southern Idaho, a feature known today as the Snake River Plain. Yellowstone is not a new volcano. It is just the current place where the plume is burning through the crust. For decades, scientists knew there was a magma chamber beneath the park. They had mapped it using seismic waves, which travel slower through hot, molten material. It was massive, but it couldn't fully explain the sheer scale of Yellowstone's past eruptions. There was a missing piece to the puzzle. Then, in 2015, the picture changed completely. A team of geophysicists from the University of Utah, led by Dr. Fan-Chi Lin and Dr. Xinhua Huang, used a revolutionary seismic tomography technique. They analyzed the vibrations from thousands of small, regional earthquakes to build a CAT scan of the Earth's crust. What they found stunned the geologic community. There wasn't one magma reservoir, there were two. The first, the one we already knew about, is a shallow chamber sitting between 2 and 9 miles beneath the surface. But their research, published in the journal Science, revealed a second, deeper reservoir lurking between 12 and 28 miles down. It's hard to overstate the size of this second chamber. It is 4.5 times larger than the upper one. Its total volume is estimated at 48,000 cubic kilometers. That is 11.2 times the volume of the Grand Canyon. 2 chambers, one stacked on top of the other, forming a plumbing system of unimaginable scale. But here is the part that allows us all to sleep at night. That magma is not a sloshing ocean of liquid lava waiting to explode. Dr. Jamie Farrell, a key seismologist at the University of Utah, has been instrumental in clarifying this. Both chambers are what geologists call a crystal mush. Imagine a sponge made of solid rock where the pores are filled with pockets of melt. In the upper chamber, that melt constitutes only about 9% of the total volume. In the massive lower reservoir, it's a mere 2%. The rest of it is solid, and you cannot erupt a sponge. For a supereruption to even become a possibility, that melt percentage needs to increase dramatically, likely to over 50%. New magma would have to surge up from the mantle plume, heat the crystal mush, and mobilize it. That is a process that takes thousands, if not tens of thousands of years, and our instruments would see it happening. The ground would deform by meters, not centimeters. The earthquake swarms would become frantic. The chemistry of the gases escaping from the geysers would shift radically. None of that is happening. Let us know in the comments if you've ever visited Yellowstone and what it felt like to stand on top of such an immense power. The official body tasked with watching for those signs is the Yellowstone Volcano Observatory, or YVO. It's a consortium founded in 2001, led by the U.S. Geological Survey in partnership with universities and the National Park Service. It is one of the most intensely monitored volcanic systems on Earth. Dr. Michael Poland, the current scientist in charge of the YVO, is the leading authority on the volcano's modern behavior. His job, and the job of his team, is to separate the science from the sensationalism. And the sensationalism is constant. Every small earthquake swarm, every change in a geyser's eruption pattern, becomes fodder for internet panic. In 2024, a hydrothermal explosion in Biscuit Basin sent steam and rock flying, sparking fears that the big one was imminent. Dr. Poland and the YVO had to publicly clarify that these are surface-level events. They are steam explosions, caused by blockages in the park's shallow hydrothermal plumbing. They are completely disconnected from the deep magmatic system miles below. Think of it like a plumbing clog in a house versus the city's main water line exploding. They are not the same thing, not even close. Yellowstone averages between 1,500 and 2,500 earthquakes every single year. The overwhelming majority are too small for a human to even feel. They are not caused by magma pushing its way to the surface. They are the result of hot water and gases circulating through the fractured rock of the Earth's crust, a constant feature of this dynamic landscape. It is the sound of the volcano breathing, not screaming. If you believe this kind of detailed, science-based explanation is critical, take a moment to like this video and share it, especially with family. It's too easy for misinformation to spread, and understanding the real facts is the first step in seeing the true picture. But what if? What if, thousands of years from now, the conditions change? What if the magma does mobilize and an eruption becomes imminent? The most dangerous myth about Yellowstone is that it's overdue. This idea comes from a simple but deeply flawed piece of arithmetic. The volcano's 3 previous supereruptions occurred 2.1 million, 1.3 million, and 631,000 years ago. If you take the time between the first and second eruption, around 800,000 years, and the time between the second and third, around 669,000 years, you can average them to get a recurrence interval of roughly 725,000 years. Since the last one was 631,000 years ago, the logic goes, we must be getting close. The problem is, volcanoes don't work like that. They are not buses running on a schedule. As the USGS and Dr. Poland repeatedly point out, taking an average of just 2 intervals is statistically meaningless. It's like flipping a coin twice, getting 1 heads and 1 tails, and declaring that every third flip will be a heads. The Earth's geological processes are far too complex and chaotic for that kind of simple prediction. Even if the math were valid, which it is not, 725,000 years minus 631,000 years still leaves over 90,000 years before it would even be due. The overdue narrative makes for a great headline. It does not make for good science. The last time magma actually broke the surface at Yellowstone wasn't a supereruption. It was 70,000 years ago, and it was a slow, creeping rhyolite lava flow that oozed out onto what is now the Pitchstone Plateau. It was a geological event, not an apocalypse. The much greater, more immediate threat at Yellowstone are those hydrothermal explosions. They happen without warning and can be lethal if you are standing in the wrong place at the wrong time. But they pose zero risk to anyone outside the park boundaries. So, the volcano is not overdue, and the magma is mostly solid. The immediate risk is effectively zero, and yet, the work of Dr. Mastin and Dr. Lowenstern remains terrifyingly relevant, because their model of ashfall distribution wasn't a guess. It was based on the physical evidence of past eruptions, the Huckleberry Ridge tuff from 2.1 million years ago, and the Lava Creek tuff from 631,000 years ago. These are layers of ancient, consolidated ash that geologists can find and measure hundreds, even thousands of miles from Yellowstone. The science shows what happened before, and it tells us what will happen again, whenever again may be. The ashfall is the true continent killer. The immediate kill zone of the pyroclastic flows, while unimaginably violent, is geographically limited to about a 100-mile radius. It's the Midwest that truly suffers the consequences. An eruption would deposit a few inches of ash across the entire agricultural heartland of North America. Iowa, Nebraska, Kansas, Oklahoma. The fields that feed a significant portion of the world would be covered in a fine layer of abrasive glass. Crops would fail instantly. Grazing animals would ingest the ash, leading to fatal dental and digestive tract abrasion. It's a mass starvation event on a scale modern civilization has never had to contemplate. The supply chain for food would not be disrupted. It would be severed, and the infrastructure would go dark. That same fine, electrostatically charged ash would get pulled into the cooling systems of electrical transformers across the country. It would short them out. It's not a matter of flipping a breaker. It's the physical destruction of hundreds of thousands of critical components in the national grid, components that take months or years to build and replace. This is not a blackout. This is electronic starvation. No power, no communications, no internet, no GPS, all brought down by a few millimeters of falling glass. Jets would be grounded worldwide. A modern jet engine operates at temperatures hot enough to melt volcanic ash, turning it back into liquid glass which then solidifies on the turbine blades, choking the engine and causing it to flame out. Air travel would stop. Not for days, for months, possibly years. The world would get colder. The sheer volume of sulfur dioxide gas blasted into the stratosphere would combine with water vapor to form tiny droplets of sulfuric acid, creating a haze that would reflect sunlight back into space. Global average temperatures would drop by several degrees Celsius, triggering a volcanic winter that could last for a decade. Growing seasons would shorten, monsoons would fail. The climate patterns that our entire global civilization depends on would be thrown into chaos. This is the real consequence of a Yellowstone supereruption. Not the cinematic fireball over Wyoming, but the quiet, grinding halt of the modern world. The slow collapse of systems we take for granted. The silence of a power grid that has gone dark for good. The end of agriculture as we know it. The scientific consensus, from Dr. Robert Christensen, the pioneering geologist who first mapped Yellowstone's ancient calderas, to Dr. Michael Pollan today, is clear. An eruption of this magnitude is an exceptionally rare event. The odds of it happening in any given year are about 1 in 730,000, far, far lower than the odds of a civilization-altering asteroid impact. It's a low-probability, high-consequence event, the kind of threat that is easy to dismiss because the timescale is so vast. But the geology is undeniable. The magma is there. The heat source is active. The history is written in the rock across the continent. Those ancient eruptions were not theoretical. They happened. The Huckleberry Ridge eruption, 2.1 million years ago, was one of the largest explosive events in the history of the planet. And I know what you're thinking, because I've seen it in the comments. I'm reminding you again, an incredible number of people watching this right now are not subscribed. If you've made it this far, you clearly find this information valuable. So, let's make it official. It's one click. It costs you nothing. It ensures you don't miss our next investigation. It's the most important way to support this reporting. Do it now. The current stability of the Yellowstone system is a testament to the complex balance of heat, pressure, and rock mechanics deep within the crust. Recent research using portable nodal seismometers, led by Dr. Fan-Chi Lin and Dr. Jamie Farrell, has allowed for an even more detailed, high-resolution map of the upper magma chamber. They can now identify the specific areas where volatile gases are trapped within the crystal mush. This level of detail confirms the volcano is in a stable, non-eruptive state. As Dr. Farrell himself stated, these findings do not change the current volcanic hazard at Yellowstone. They just allow us to see the sleeping giant more clearly than ever before. The real story of Yellowstone is not one of impending doom. It is a story of geological time, of processes that operate on scales that dwarf human history. The continent is alive. The ground beneath our feet is not static. The forces that shaped North America are still at work, quietly, relentlessly, miles beneath a national park. The 7 states that would vanish in an eruption are not living on borrowed time. They are living on a continent that is still being formed. The danger isn't that Yellowstone is overdue. The danger is in forgetting what it is. It is the surface expression of one of the planet's most powerful engines. An engine that is currently idling, but one that will not idle forever. Whether that forever ends in 10 years, or 100,000 years, is the question that keeps the lights on at the Yellowstone Volcano Observatory.